In this video, we will continue our discussion about classes and objects in Java. So, after completing this module, you'll be able to design classes using UML, which is Unified Modeling Language, explain and utilize encapsulation, explain the use of static keyword, implement classes in Java, explain and create constructors, setters, and getters, and finally, you will be able to pass objects as parameters. Now let's first start talking about UML. So classes in Java can have attributes, which is the data that we want to store for our objects, and methods, which are the operations that we want to apply to our objects that we create. So in UML, we'll draw classes as boxes showing the attributes and methods. So in this example, what I have is a class that is represented by this whole box, and the class's name is rectangle. So the box will contain three parts. The first part is the class name, the second part is going to be the attributes, and the third part is going to be the methods, which are the operations that will work on that class. Now, we will represent the attributes by the attribute name and then a colon and then the data type. Now, as you can see, we have pluses and minuses here. So I have a minus sign here and I have a plus sign here and I have pluses for all of those. And this is encapsulation, which we'll talk about in a bit. And you will see why do we use this. But the representation of the attributes is going to be the attribute name and then the data type. So this is going to be the variable name. Length, for example, and width are going to be variables, or what we call instance variables, which are going to be holding the attributes of each object. For methods, however, it's going to be the method name, and then in parentheses I have whatever the argument types I'll have there. So I will not say this has to be this name. I just care about the type because the naming here is going to be based up to the programmer, but I need to care about the sides here. So I will have a method that's called rectangle that will accept two doubles, and if you notice that this is the same as this one, and we will talk later about this, but this is what we call a constructor, and we will talk about more detail later on. Now I have another method that's called area, and this is the return type. Now I don't have any return type here because it's void, but this is going to be a return type. So for methods, it's going to be either plus or minus, or we will see later on that we have something like a hashtag. So encapsulation followed by method name, and then we will have arguments, if any, and then I will have return type only if it's not void. So if it's void, I will not include any return type. So this is a method that's called area, doesn't take any arguments, and the return type is double. Again, parameter doesn't take any arguments, return type is double. Info doesn't take any arguments, return type is void because I don't have any colon, I don't have anything in here. You don't put a colon and then say void, you just leave it without anything. Set width takes a double, return type is void. Set length takes a double, return type is void. And this is a general way on how you show your classes in UML notation. Now I just talked about the encapsulation, so let's see what do we mean by this. But first let's talk about some modifiers. So a modifier in Java is a keyword that changes the meaning of a variable or a method. So we will have two types of modifiers: access control modifiers and non-access control modifiers. So for access control modifiers, we'll have these three, public and private and protected, which is going to be the encapsulation that we are talking about. And for these, we have seen the final keyword or the final modifier, which is going to change the variable to a constant. And we have seen static with methods, and we'll talk about static in more detail in a bit. So for encapsulation, we have three levels of encapsulation. Encapsulation is basically protecting the attributes of a class object from being altered by another class or program. We'll see later on, if you define something as public, it can be accessible from any other class, and then it can be altered. So we don't want to allow that in certain cases, so we will introduce encapsulation. Now we have private, public, and protected. So if the attribute is private, it's going to be accessible only to the methods of the class in which they are contained in. So if we go back to the rectangle example, if I declare my variables as private, I can access them only from that class. If I try to access them from the driver class or the demo class, we will not be able to do so. Now this is going to be denoted by a minus sign in UML. Now you recall that we've seen minus signs here, which are basically telling me that those are private. So what about the plus sign? So for plus sign, it's public, and public is, it's going to be accessible to methods of the class and other classes. So anything that's denoted by a plus sign is public, and it can be accessed from other classes. As we've seen, the methods are all public, so they can be accessed from the demo or the driver class. Making them private will allow access from other classes, which is what we want for our methods. Now the last one is protected, and I will not talk about this into more details until we cover inheritance, but this is going to be accessible only to the methods of the class and subclasses, and the concept of subclasses is something that we will talk about in the next chapter when we talk about inheritance. But what you need to know for right now is it's going to be denoted by a hashtag or a hash sign, which is going to tell me that this is protected. Now let me just finish this video or discussion by talking about the static keyword. Now a static variable or method does not need an object to be accessed. So remember, if we declare something in a Java class, so supposing that this is my Java class and I have my main method here, and then I have some code in here, and I have a method here, so let me call it M1. Unless I make M1 static, I cannot access it right away from my main method right here. I have to create an object for that. And other uses, a static field will be the same across all class instances. What does this mean? So if I, for example, have a class for bank account, okay, and let's make this uppercase. So if I have a class for bank, and then I have some kind of interest rate. So if I want to make this interest rate the same for all accounts that I will create, I will make this static. So static will guarantee that this interest rate is going to be the same for every single object. Now, if we declare a method static, it cannot be implemented in subclasses, and we'll have more details in the next chapter as well when we talk about inheritance. So we have these uses for static. A variable or method will not be accessed with an object, so we don't need an object to access the method. When we declare the method as static, we can access it right away from the main method. And if we declare a field or a variable as static, it's going to be the same across all objects from that class. And if we declare a method static, It cannot be implemented in subclasses, which means we cannot change the implementation of the method in the subclasses if we declare it as static.